Leaving the space station, walking on the moon, fixing the outside of the ship. You can't do any of these things without a spacesuit. Space is a vacuum. There's no air. Temperatures can vary from extreme heat to extreme cold, not to mention the dangers from radiation. You're going to need your own portable life support system to stay alive, with a pressure inside the suit that is about a third of what we experience here on Earth.
So the spacesuit is a really important device in order to allow us to explore and to fix spacecraft and to perform geology on the surface of the moon, or maybe one day on the surface of Mars. But because it's pressurized to about a third of an atmosphere, that it kind of has a stiffness to it.
These are all very important tasks, but so is breathing. So how do we breathe in a spacesuit?
Just like you do here, well, at least for breathing. So it's all oxygen on the inside, whereas here we have a lot of nitrogen in our air, but we give folks pure oxygen at a lower pressure, so that way they're able to breathe just like normal.
When astronauts work in space, they might need to wear the suit for several hours. It's important to stay hydrated, but you can't just lift the visor and take a drink of water.
Now for water, what happens is they have like a body-mounted or a spacesuit-mounted drink bag with a little hose, a little straw. And so when the astronaut is thirsty, because they're doing a lot of work inside the suit, they can just reach down and take a drink out of that bag.
Now, let's hear about mobility and how astronauts move.
And so we spend a lot of time and effort trying to design that suit so that way it's as mobile as possible, so that way the astronaut inside can get all of their work done.
Spacesuits over time have evolved, turning into spacesuits of the future.
Water. It's precious. It's what makes life possible. For those of us on Earth, we can get water in many places. But if we're living in space, did we say that water is precious? The average water use per person is 200 gallons. Try launching that much into space.
You know how expensive it is to send a package to space? No matter what's in it, water or anything else, it's about $2,000 a pound.
So, if you're an astronaut, the best way to attain water currently is recycling.
The astronauts recycle almost all their water. So if you do the dishes, water goes into the dirty water container. If you take a shower, they have a little sponge shower squirter thing. The water goes into the dirty water. If you pee, it goes into the dirty water. And all of this goes into a machine, and the machine distills the water to make it clean.
The water filtration systems developed by NASA are also being used to conserve water on Earth.
Backstart. Copy during backstart.
I'm actually C3 good day.
Copy C3
We're going to go.
What's more thrilling than to watch a rocket launch? NASA's Space Shuttle was the world's first reusable spacecraft. It was capable of launching like a rocket and landing like a plane. For a spacecraft to succeed, its design must be practical. It needs everything to carry payloads along with people, have a life support system, and a way to pilot it.
You have to have all of the things that every spacecraft has. Life support, which means air and food and all those things. You really want windows because you want to be able to see things outside. And of course you have to have entry systems. There's all those things. You would like it to be bigger, but the problem is big spaceships require much bigger launch vehicles to get to space, so we're not really ready for that yet.
To get where it needs to go, a spacecraft must have a propulsion system to give it thrust.
The space shuttle was a very interesting hybrid. The main engines for the airplane part were powered by liquid hydrogen and liquid oxygen, which pretty interesting because what do you get when you put hydrogen and oxygen together? You get water. So what came out of the back end of the space shuttle was actually steam. So it was really, in some ways, a steam-powered spaceship.
Chemical rockets are good for launching and escaping Earth's gravity, but the fuel gets used up quickly and results in heavy payloads. Ion thrusters propel spacecraft using an electric charge. They can power spacecraft at higher speeds and with more efficiency.
Well, there's an awful lot of research going on right now for propulsion systems of the future, and some of them are kind of in use for a spacecraft that can go, it can take a long time to get somewhere. There are ion-powered engines which use an electrical process to really energize tiny particles and shoot them out the back end at really high speed. They don't have very much thrust, but over a long time they can really build up a lot of power and a lot of velocity addition.
Spacecraft design isn't simple, but lots and lots of people are working on it right now and making breakthroughs that could help us for centuries. They are working on one of the most critical needs for space life, the spacecraft.
Space is a very cool place. A place few people are ever able to experience. But there's a way to bring space to those of us stuck on Earth. Well, at least getting us to see what the view is like in space. The way this could be done? Planetariums. They're like a window to the stars. Nick Connon is the digital theater specialist at Fisk Planetarium in Boulder, Colorado, and an expert on visualizing space.
My favorite part about working at the planetarium is being able to inspire and engage people who look up at the night sky and want to learn more about space, because space is something that reaches everybody and I want to help bring it to them using the planetarium.
To get those amazing visuals on the dome, video is projected at a resolution of 8K. That's ultra high definition, a resolution that makes you feel like you're there.
The footage, well, it's a giant computer simulation. So we're kind of simulating what you'd see in the real universe. And in fact, a lot of the data that we use for the stars that we look at, the constellations, the planets, all are things that were developed by astronomers for the last 1,000 years.
To project stars, Fisk uses what is called a starball, capable of accurately reproducing the night sky using millions of stars. What makes Fisk unique to most planetariums is that it uses both the starball and IMAX quality video projectors, which practically immerse audiences into the scene.
The starball projects 10 million stars as if you're actually outside looking at the stars. Our normal digital projectors, even though it makes an 8K image and it's many IMAX screens worth of pixels, the stars still have a size. They don't look like just little pinpoints, little pinpricks of light. So the starball gives us that accurate pinprick of light effect.
So if you're feeling a bit earthbound today and you want to take a moment to gaze into space, planetariums are your vehicle to the stars.